Hi, this is Claire, and today I'm going to show you how to draw a Pythagorean spiral. And I've completed one here. And actually, I happen to be wearing some Pythagorean spirals that I've made in jewelry making. So let's have a look at how we're going to construct these. You're going to need a ruler and a pencil, a rubber, sharpener, and a calculator. So let's have a look at these. The first thing I want you to use is your grid paper, and to remember that the base of the triangle is going to change, but the height will always be exactly 1 centimetre high. So drawing your first right angled triangle, we'll use the base of 1 centimetre and the height of 1 centimetre and form the hypotenuse. So you can see the first one, and there's the right angle. The next one you're going to draw is going to be on top of the first one. So the hypotenuse of the first triangle, this length, will be the base of your second triangle. So as accurately as you can, and I can tell you that a set square would really help you here, but I don't have one. So construct the side of that as 1 unit, form your hypotenuse, and there's your second right angled triangle. Now, the hypotenuse of that second triangle is going to be the base of the third. So as accurately as you can, draw a right angle with the height of 1 unit and form your hypotenuse. There's the third triangle, and you can see the spiral starting to form. Your next triangle uses the base of the hypotenuse of the previous triangle to form the base. So again, it's accurate estimation as I can. I'm drawing a right angled triangle and the hypotenuse. So keeping on with this, we might draw 2 more, and then I'll let you finish it, stop the tutorial and draw a few more. So again, the hypotenuse of the previous triangle forms the base of the subsequent or the next triangle. Perhaps draw 1 more, keeping this accurate, hoping that I'm not going out of your view. So up we go. There's the height, 1 unit, and there's the hypotenuse. So if you'd like to stop this tutorial, you can draw a bit more of your spiral so that you can clearly see it increasing around here, and there's lots of patterns here. The inside of this, you can see that angle is becoming smaller. The hypotenuse is becoming longer, which helps you see the spiral, and you can see that spiral is going around. It looks a bit like a shell. Okay, so if you want to stop it and do a bit more of your spiral, draw a bit more of your spiral, and then rejoin me, I'm going to talk about the patterns we can see. So to observe the patterns, I'd like you to draw a table, and the first column of the table is the number of triangles, or it's the first triangle and the first hypotenuse length. The next column is going to be the length of the hypotenuse, the working, and the third is the answer, so A for answer. We're going to use the Pythagorean theorem to calculate the length of the hypotenuse, and as you know, the hypotenuse squared equals a squared plus b squared. I've been working with that. Now let's just rearrange this a little bit to make h the subject of the formula. At the moment it's h squared, but we're going to just rearrange it to make h the subject of the formula. So take the square root of both sides. The square root of h squared simply equals h, because the square root and squaring are inverse operations of each other. So the square root of 2 all squared simply equals 2. They cancel out. I'll talk about that a little bit more in a moment. So the square root of h squared equals h, and the square root of a squared plus b squared is the square root of a squared plus b squared. It can be written like that. Sometimes you might see it written like this, with the square root and then a bracket, a squared plus b squared. You often see it written like that, and those two are the same. So let's work out the length of this first hypotenuse. You can see that first hypotenuse. The base is 1 and the height is 1. So going over to our table, drawing our radical sign, 1 squared plus 1 squared. We're finding the square root of 1 squared plus 1 squared, which equals the square root of 1 squared is 1 and 1 squared is 1. So the square root of 1 plus 1 is the square root of 2, and that's the answer. So going back to this diagram here, that first hypotenuse length is root 2. Now the next one, which is this hypotenuse here, the base of that triangle is root 2 and the height is 1. So we're going to use this concept again of the square root of 2 all squared. So let's write this down in our table. So the square root for the second hypotenuse is 1 squared plus root 2 all squared. Okay, which equals the square root of 1 plus, let's check this on our calculator. So pick up your calculator and turn it on. And we'll put in a bracket because this is important, it's a bit tricky. So open the bracket, choose the square root button, square root of 2. Just hop across, close your bracket and square it. Now choose equals, and as you can see, the square root of 2 all squared equals 2. So we can enter that into our formula over here in our table. The square root of 1 plus 2 is the square root of 3. Going back to our diagram, and we can put root 3 as the length of the second hypotenuse. The height is 1, and we're going to find the length of the third hypotenuse. Back to our table. Square root of 1 squared plus root 3 all squared, because we do need to square it. Okay, root 3 all squared. What do you think that's going to equal? Root 3 all squared. Because the square root and the square cancel out, it'll simply be 3. You can check that on the calculator. So clear this, open the brackets, square root, 3, close the brackets. Oops, we just got to go outside of that. So we might just delete that one. Just deleted everything. We'll just start that again. Root 3, hopping out of it and square it, equals 3. Okay, so we've verified it. So on our table, 1 plus 3 equals the square root of 4. Okay, we know that the square root of 4 is actually 2, but we're going to leave it as root 4 so we can see our pattern. So going back to this diagram, we'll put on root 4 and the height is 1. So let's do the next one. It's the fourth hypotenuse. In your table, 1 squared is the height The base is root 4. Square it. So the square root of 4 all squared, we can work this out. The square root of 4 is 2. So 2 squared equals 4. So we can actually use our math skills to verify that one rather than using the calculator. So back in our table, 1 squared is 1, root 4 all squared is 4, which will equal root 5. So let's put this in our diagram. The next one is root 5 and the height is 1. Okay, can you see the pattern? The length of the hypotenuse are root 2, root 3, root 4, root 5. The next one, root 6, root 7, root 8. Very interesting little pattern in the Pythagorean spiral. So that's the pattern, and there's lots of learning in this particular activity. You can see that the square root and the squares are inverse operations. We've been able to rearrange the formula so it's nice and simple for us to use in a nice handy format. That's why we rearrange formulas. Another interesting thing here is that you can see that root 2, the length root 2, does have a physical length. So although root 2 is an irrational number, which has an infinite number of decimal places and no recurring pattern, so if we turn the calculator on, and it's not turning on, there it is, root 2, sometimes the calculator likes to be rested on a table, equals, there's no pattern, we have to round it off. So it's an irrational number, but because it has a real length in our diagram, we can see that it is also a real number. So real numbers are rational and irrational numbers. So even though root 2 is irrational, 1.414213562, no pattern, it's irrational. This is an irrational number. It is still in the real set of real numbers. It's still a real number because it has a length. Who would have thought that? Okay, so continue your spiral and continue your pattern, and maybe you can find some other patterns with Pythagoras. Bye for now.